So we have a few problems to look at tonight. The first one is the square root of 4f is equal to x plus y. According to one of the laws of indices, we know that x, the square root of x is the same as x to the power half. Using that law, we go ahead and rewrite 4f to the power half. And this half applies to both the 4 and the f. Let me say at this point, another law of indices tells us xy squared is the same as x squared y squared. So using those two laws, we're going to move on. The square root of 4f could be rewritten as 4f to the power half. The same thing on the right, we haven't changed anything. Now we're going to square both sides. What happens is we can go ahead and square the left side, and by using that we can cancel out the powers, because there's another law that tells us x squared to the third power is the same as x 2 times 3, which is x to the 6th power. So that's the first one we've used. This is the second principle we need to know, and the third one, where you multiply the exponents, the one on the term and the one outside the bracket. And so we use that to get rid of the square root sign. That's how we got rid of this square root. So right now this 4f is all by itself. On the right side, if we square the left side, we have to square the right side also. On the right side we square it and we get x plus y times x plus y. And that becomes x squared plus 2xy plus y squared. And you could try that and see x plus y squared is not the same as x squared plus y squared. They're not the same. The reason is because this will require the foiling, so x plus y, and you can play around with that using the foiling method. The first term multiplies the first term multiplies the second term multiplies the first, and the second term multiplies the second. Using that method, you get x squared plus 2xy plus y squared. Then we go ahead and divide both sides by 4, and that will give us the value of f. So this problem is simply learning how to make f the subject of the formula. And that's how you go about it. Step by step, I hope that you can see how I got from the square root of 4f is equal to x plus y down to f is equal to x squared plus 2y plus y squared over 4. I have a few more examples of this, and I hope that it will make more sense as we keep going. That's how you deal with making things the subject of the formula. So let's move to the next question. The next one tells us the cube root of 6y plus x is equal to 7. Using the same principle, we can rewrite 6y plus x as 6y plus x to 1/3, and then we cube both sides, and so on the left side we'll get 6y plus x, and on the right side we'll get 7 cubed. 7 cubed is 343, and then the next thing we do is we subtract 6y from both sides, and that will give us x to be 343 minus 6y. So in this question, we're solving for x. The next question gives us, we have a square root of x plus 1 minus 3 is equal to 5. We're also solving for x. The first thing we do is we move everything that is not in the square root to the other side. If we have that chance, and since we have that, we're going to move the minus 3 to the other side by adding 3 to both sides. So we add plus 3 to this side and plus 3, and that becomes 0. There's no more, we don't have a constant on the left side now, but we have 8 on the right side. In the square root, we now, this is where you learn how to use the principle I just taught. You go ahead and square both sides, and so that will get rid of the square root here. It becomes simply x plus 1, and on the right side you also square it, and you get 8 squared. So x plus 1 is equal to 64, and then at this point you just subtract 1 from both sides, and x will be equal to 63. So let's move to the fourth problem here. The square root of 3g is equal to 8. Using the same principle, we know that 3g to the power half, that's what the square root of 3g means, 3g to the power half. And we go ahead and square both sides, and so if we square this side, all we'll get is 3g. If we square the right, we get 64. And so g would be equal to, after we divide both sides by 3, g will be equal to 64 over 3. I hope this is beginning to make sense. We have one more example of this as we round up. The fifth root of 3y plus x is equal to 2. Again, using the law that we talked about, the fifth root of x would simply be x to the power 1 over 5. And so that becomes 3 plus y to the 1 over, so to the power 1 over 5 is equal to 2. We take them to the fifth power, both the left and the right side, and we get 3y plus x on the left side, and on the right side we'll get 2 times 2 times 2 times 2 times 2, which is 32. And at this point, we subtract 3y from both sides, and we'll get x is equal to 32 minus 3y. That's how you do that problem. Let's round up with questions on the quadratic formula. The quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a. Let's just learn how to substitute values in and see what we get. We're going to put 1 every time we see a, put 4 every time we see b, and 3 every time we see c. And using that, we're going to put minus 4, so that's our b is 4, plus or minus the square root of 4 squared minus 4 times 1 times 3 over 2. We've put all the values in. Minus 4 plus or minus 16, the square root of 16 minus 12 over 2. And then the next step is we just simplify. Minus 4 plus or minus the square root of 4 over 2. Now, anytime you see this, plus or minus, it means that you would have two answers. Or you could have two answers. And so it becomes minus 4 plus or minus 2, because the square root of 4 is 2 over 2. Minus 4 plus 2 over 2, or minus 4 minus 2 over 2. Those are the two possible answers we could get. Again, this is y. So we could either get this answer using the plus, or we could get this answer if we use the minus. And that becomes minus 2 over 2, or minus 6 over 2. So we have minus 1 or minus 3. We know that if we use the AC method for this problem, it will simply be x squared plus 4x plus 3. And our AC in this question is 3. Our B is 4. We look for two numbers that when we multiply them, we get 3, and when we add them, we get 4. And those numbers are simply 3 and 1. So that's how you do that problem. This question, we're going to quickly do it, and then I'll leave you with an assignment. 2 square root of 2x minus 1 is minus x is equal to 1. You go ahead and take the x to the other side by adding x to both sides, and then you square both sides to get rid of the square root in here. That gives you 2 squared and then 2x minus 1 squared. So that's 4 into 2x minus 1. We go ahead and distribute. We get 8x minus 4, and that's the left side. On the right side, we go ahead and FOIL here, and we get 1 plus 2x plus x squared, and then we subtract 8x from both sides, and then we add 4 to both sides. So we then get 0 is equal to 5 minus 6x plus x squared. I want you to take this and use the AC method and the quadratic formula to solve this. So there will be two different things I want to see. And A is 1, B is minus 6, and C is 5. Try using the quadratic formula and let me know how it goes. So I hope you have a good evening. That's all we have for today.